Okay, let's do problem 2a. Now the circuit is given here, and in problem 2a we've been given RB equal to 100k. Okay, so let me write that. So this is 100 kilo ohms. Okay, and now we have to find out uh, the values of VB, VC, and VE. Okay, this is a circuit where you think, okay, where do I start, right? Because usually, if you know the base voltage, then you can calculate VE, and then you can calculate IE, and you can go from there. But in this case, you don't know that. So, so the question is, okay, where do I start from that? Start here. And I think the way to start it would be to say, okay, since I don't know the base voltage, either I assume a base voltage or I assume a base current and start from there and solve the problem. You see what I mean? Okay. So let's say we assume a base voltage. We say, okay, let the voltage at the base be VB. And now we'll write equations so that we can get the solution. Now we can calculate the value of VB. Now there are a few other things given in the circuit, right? We have been told that beta is equal to 100. Okay, let's also assume that the transistor is in active mode. Okay, we'll have to verify this, but we'll just assume that this is an active mode. So if this is VB, what is VE equal to? VE is going to VB minus 0.7 volts, right? And if that is the case, what is IE going to be? IE, I can write here, is equal to VB minus 0.7 divided by 1K. So that's IE. All right, that's good. Now we can also write IB, isn't it? Now how do we get the value of IB? Take a look. This is 5 volts. This is VB. So you can calculate IB, sorry. So IB is going to be 5 minus VB divided by 100 kilo ohms. Now, is there a relationship between IB and IE? Yes, there is, isn't it? We know that IE is equal to beta plus 1 IB. Now let's just put the equations. So let's call this 1, 2. So let's substitute 1 and 2 in equation 3. So what do we get? We get VB minus 0.7 divided by 1K equal to 101 times 5 minus VB divided by 100K, right? And you can solve this equation to get VB. Does that make sense? So if you solve the equation, you should get VB is equal to 2.9 volts. Now, if VB is 2.9 volts, what is VE going to be? It's going to be 2.2 volts, which means IE will be 2.2 milliamperes. Okay, so if IE is 2.2 milliamperes, what is IC going to be? Right, IC is going to be beta divided by beta plus 1 IE, which is equal to 100 divided by 101 times 2.2 milliamperes, which you can calculate. It comes out to be 2.18 milliamperes, and that helps us to calculate VC, which is going to be 5 minus 2.18 milliamperes times 1K, and that turns out to be 2.82 volts. Okay, so once we've got that, now let's check. Remember, we started off with the active mode assumption. So is the transistor in active mode? Look at VC. So VC is 2.82 volts here, and VB is 2.9 volts. So you can see that this base collector junction is still in reverse bias, and therefore uh, the transistor is in active mode, and so we are done, right?